Bismillahirrahmanirrahim. Assalamu alaikum students. How are you? I'm your instructor Iqbal Shoukat. Today we'll talk about the binomial distribution. In the last lecture, we talked about the probability and we came to know how and where we can apply the probability laws. Today, we'll proceed further and we'll talk about the binomial distribution. Regarding to the binomial distribution, if we talk about binomial, what is the binomial? Bi means two, where we have to talk about the result or outcomes of any experiment, which will be two. We'll discuss that. If we talk about the binomial distribution, a distribution or a discrete distribution, where we have to concern regarding to the discrete probabilities. If we talk about the binomial distribution, a distribution where we'll discuss the probabilities of the binomial experiment or the Bernoulli trial, a trial or experiment which has only two possible outcomes, that is known as the binomial experiment. Regarding to the binomial distribution, as Allah has created the concept of the universe on the basis of the binomial system, day and the right and the wrong, hell and heaven, by regarding to the gender, male and female. On the same pattern, students may fail, student may pass. There are two chances, two outcomes. When there will be only two possible outcomes, possibilities of return, there will be two, that is known as the binomial distribution. If we talk about the probability, it is that branch of mathematics concerning numerical description of how likely an event is to occur or how likely it is that a proposition is true. If we talk about the probability, whether it's the binomial distribution, discrete distribution, or simple distribution, we have to apply the concept of the probability and the answer range would be the same. If we talk about the probability answer, its range is from 0 to 1. Closer to 1, more strength, more reliability, more working. We'll come to know what is happening there. Probability and the binomial distribution, they are strongly correlated. This is the part of, it is the subgroup of the probability. From today's lecture, what the student will come to know, what would be the learning outcomes for today's lecture, that will be students will be able to understand the terms regarding to experiment, output, independent and mutually exclusive events. Then students will be able to understand the probability scale and be able to interpret possibilities of the probability. Then they'll come to know the basic laws of the probability. That can be the multiplication law, that can be the addition law. Then they'll come to know the characteristics of the binomial distribution and how the binomial distribution relates to the practical life. Then the students will come to know that how they can look up probabilities for the binomial distribution on a table. Then at last, students will be able to understand, to know when you would use a binomial distribution. Under what sort of data we can apply the binomial distribution? As I told earlier, when the distribution will be in binomial nature or discrete nature, then we shall apply the binomial distribution. As far as the binomial distribution is concerned, it shows how a distribution can take place, how the probabilities can take place, how the action can be performed, all depends upon the binomial experiment as well as the binomial distribution. If we talk about the binomial distribution, what is the binomial distribution? A distribution or a function that assigns probability of occurrence to each possible outcome of a random event. Random, that is the independently selected event. As we are talking about the binomial distribution, bi means two. A binomial distribution is a specific distribution It is used to the model of probability of obtaining one of two outcomes. A certain number of items out of fixed numbers of trials of a discrete random event. It is known as the binomial distribution. If we talk the binomial distribution or the binomial experiment, how it reacts, how it behaves, two outcomes, two resultant flow, we can get the advantage, we can get the benefit. Our binomial distribution has two outcomes. The expected outcome is known as the success, whereas the failure or any other occurrence that can be the failure, which is represented with the help of q. The probability of success that would be represented with the help of p, whereas the probability of failure that would be represented with the help of q. P plus q will always be equal to 1. So 1 minus p, that is equal to q. Q is the probability of the failure. Next one is how we'll come to know that we have to apply the binomial distribution. Under what rules, under what conditions we have to apply the binomial distribution. The binomial distribution is used to model the probabilities occurrences when specific rules are met. Rule number 1, there are two mutually exclusive outcomes for a discrete random variable that can be success or the failure. As I told, mutually exclusive events, the events which can't occur together simultaneously, the events which can't occur jointly. For example, a success has taken place at the same time failure can't be there, or if the failure has taken place, success can't prevail there. It's all about the binomial. Second one is the experiment would be repeated for a fixed number of time. Fixed number of time, 5 times, 10 times, 100 times, it is a fixed number of repeated times. The probability of success is represented with P and the probability of failure that can be represented with Q. Third one is each trial is an independent event, meaning the result of one trial doesn't affect the results of these subsequent trials. Each trial is independent. Whatever the action, whatever the performance, what sort of experiment you want to perform, you can do that. You need not to depend upon other people, on the other experiments. Whatever the experiment, whatever the action you want to take, you can take independently. There shouldn't be any restrictions. There shouldn't be any boundaries regarding to the binomial distribution. Next one is the probability of success for each trial is fixed. That is, the probability of obtaining a successful outcome is the same for all trials. If we're talking about the trials, what sort of trials, what sort of activities can be performed, can happen there, that's all about the binomial distribution. Next one is the properties of binomial distribution. Before solving the questions of the binomial distribution, these properties should be kept in mind. The mean of the binomial distribution mu x, which is equal to n into p, whereas the variance sigma square, that is equal to n into p into q, n, p and q. Here is the variance, and if we want to find the standard deviation, that is the positive square root of the variance. And then in a binomial distribution, the trials are considered to be independent and identical. Whatever the result we will get, that will remain the same for all the trials. Probability of success remains the same throughout the experiment. Whatever the experiment we are performing, that will remain the same throughout the process. The conclusion: one trial does not depend on the conclusion of the others, and all the trials have equal probability. Then there is a special case of binomial distribution where the number of trials is 1. There is a special case of binomial distribution where the number of trials is 1 Number of trial is 1. 1 is the performance. Then the distribution is known as Bernoulli distribution. Only one output, only one outcome, only the one result, only the one trial, that is known as the Bernoulli distribution. But the outcomes of the Bernoulli distribution will also be the two. That can be success and failure, true and false, right and wrong. Now let's come towards the formula of the binomial distribution. Under what conditions we apply the binomial distribution, as it has been discussed in the previous slide regarding to the properties or regarding to the conditions of the binomial distribution. Trial should be independent, experiment should be performed for a specific number of times, and so on. Now let's have a look regarding to the formula of the binomial distribution. Here is the formula of the binomial distribution, which is equal to probability of capital X equals small x, which is further equals n cx into p power x q power n minus x, where p represent the probability, capital X, that can be the any random variable, x equals successive trials, and n the number of times experiments performed, and c stands for the combination rule, whereas p the probability of success, and q stand for the probability of failure, where x equals 0, 1 to 3 and so on n. So whatever the experiment has been performed, it has been done, that would be performed, that would be acted according to n times, where activities would be performed, action would be taken, that would be regarding to the binomial distribution. Here see the combination, p the probability of success and q the probability of failure, and see the combination rule, when the arrangement of the objects or data will be without a specific order, then we shall apply the combination rule. Let's have a look regarding to the numerical example of the binomial distribution. For example, 80% of people, those who purchase state life insurance, are women. If the owners of 9 state life insurance are randomly selected, then find the probability that exactly 6 out of them are women. We are talking about of the people who purchase state life insurance are women. It means the probability of success, that is 80%. That means 0.80. While on the other side, if we talk about the 9 people, are there 9 life insurance policies or the 9 companies has been taken, it is the n. And whatever has been asked, that is known as the successive trials. So first of all, we will write down the information. X equals any random variable, where small x equals successive trials which are equal to 6. Whatever is being asked to calculate, that is known as the successive trials. Whatever is being asked to calculate, that is known as the successive trials. Small n, the number of times experiment performed, which is 9. If the owners of 9 state life insurance, that means 9 companies are there, 9 owners are there, 9 people are there, then q is equal to, c is equal to combination rule, the arrangement of objects without a specific order, that we shall apply the. Next one is the probability of success, which is equal to 0.8 or 80%, which is equal to 0.8 or the 80%, and then q is the probability of failure, which is equal to 1 minus p, which is equal to 0.2 or the 20%. Then probability of capital X equals small x equals ncx p power x q power n minus x. Then we shall apply the formula, probability of capital X equals small x is equal to 9c6 into 0.806 or then 0.20 into 9 minus 6. We are going to apply the values in the given formula. N is the 9, C the combination rule, X the successive trial 6 into P the probability of success, which is equal to 0.80, and raised power 6, then probability of failure, which is equal to 1 minus P, which is equal to Q, 0.2 raised power 9 minus 6, raised power 9 minus 6. Then the total answer after solving through the scientific calculator, the end result is 0.176. And if we want to find the answer in percentage, we shall multiply the answer with the 100. We will get the percentage of the given answer. Then next one is regarding to the binomial distribution. There is another example. If only 5% kids can score A grade in a paper, in a paper, find the probability of at most 2 out of 10 kids getting A grade in that paper. Here you can see only 5%. 5% is the success rate of the A graders, which is equal to 0.5 or 0.05. A grade is in a paper, find the probability of at most 2. At most means maximum 2 students can get the marks or they can get the A grade. Maximum 2, that means 1 can be there, 0 can be there. Maximum is 2. Whereas 2, 1 and 0 can be there. Out of 10 kids getting A grade in that paper, 10 kids, that is the n. N is the 10, whereas P, probability of success, which is equal to 0.05, and probability of failure, which is equal to 0.95. So we have to apply the formula of probability of x less than equals to 0, probability of x equals 1, and probability of x equals 2. So it is the combination of these three probabilities. Whatever the action in the previous, we just have to enter the values in the formula. But this formula will be written in regarding x equals 2. So 10C0, 0.05 raised power 0, 0.95 raised power 10, plus regarding to 1, 10C1, 0.05 raised power 1, or then multiply by 0.95 raised power 9 plus 10C2, which is further equals to 0.05 raised power 2, 0.95 raised power 8. So the values are 0.598 plus 0.315 plus 0.074, which is further equals to 0.988. So the probability needed is 0.988. If we talk about if only 5% kids, that means there are 98.8% possibility that out of 10, at most 2 students will get the A grade. At most is the maximum range. We have to start from the 0, then travel towards the 2. And if the word at least would be defined, the starting point would be there of at least, and then the maximum time the experiment has been performed, we'll apply the same probability over there. It is regarding to the numerical of the binomial distribution. Now let's have a look of the calculation. So that means 98.8% people or kids can get the A grade if there are 10 students, and at most 2 students will get the A grade. That means no student is getting the grade. Only one student is getting the grade and 2 students are getting a grade. That means 0 plus 1 plus 2, that is equal to 0.988, which represents the 98.8% people represent the probability or the possibility of occurring or happening of an event. Next example, if a coin is tossed thrice, or 3 coins are tossed once, that represent the same. Then find the probability of getting a head at least 2 times. Find the probability of getting a head at least 2 times. Then, if you're talking about the probability of getting head at least 2 times is the sum of probabilities of getting head 2 times, that means, or 3 times. At least 2, as I told, that is the starting point, and the maximum number of times the experiment has been performed, we shall apply the cases on that. Thrice, twice and thrice. Probability of x equals 2, plus probability of x equals 3. So it would be equals to 3c2 into 0.5 square, that means regarding to 2, then 0.5 1, plus then 3c3, 3 out of 3, 0.5 raised by 3, then 0.5 raised by 0, which is further equals to 3 into 0.125 plus 1 into 0.125, which is further equals to 0.5. Hence the needed probability is 0.5. It means that if three coins would be tossed and at least two heads will appear, it will represent the 50% chances are there at least two heads will appear. That means head, tail, head, 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 tail, head, head, head. That means at least 50% chances are there at least two heads may occur. On the same pattern, same process regarding to the binomial distribution, there is an example regarding to the placement of the location. If a committee has 7 members, find the probability of having more female members than male members, given that the probability of having male or a female member is equal. Here we are saying the probability of female members that is more than the male members. There are total 7 members. 3 can be the men and remaining 4 can be the women. So probability of x we have to find that will be more than equals 4. That means more men, 3 men has been subtracted. The less one is the 4 that represents the women. X equals 4, 5, 6 and 7. Then we have to calculate 7c0. Then we have to apply the values in the given formula. It is the formula. Here we have to insert the values 7c4, 0.5 raised by 4, 0.5 raised by 3. Plus again 5, we have to insert the values in this formula 7c5, 0.5 raised by 5, again 0.5 raised by 2. Then on the same process, we will apply all the values and we'll find the solution. And the end result is 0.50, which represent that if a committee has 7 members, the probability of having more female members than the male members, that would be 50%, 0.5. For today's last slide is, and the last numerical is, the probability of winning a match for team A is 0.6. Then find the probability of winning 3 matches out of 5. 3 matches out of 5, that means total is the 5, winning are the 3, and the probability of success, which is equal to 0.6. Probability of winning, which is equal to 0.6. Probability of losing q, which is equal to 0.5. That means 1 minus 0.6, which is equal to 0.4. Then probability of winning 3 matches out of 5, that would be regarding to probability of x equals 3, 5c3 into 0.6 raised by 3, 0.4 raised by 2. Then probability of x equals 3, 10 into 0.216 into 0.16, which is equal to 0.3456. So there are 34.56% chances that out of 5 matches, 3 matches would be successful, or they will win the 6 matches. If you're being asked to find the binomial mean and the binomial variance, so you can see the formula. If mean is being asked, the formula is n into p, n is the 5, whereas the probability of success, which is equal to 0.6. So 5 into 0.6, which is equal to 3. Then variance, which is equal to npq, which is further equals to 5 into 0.6 into 0.4, which is equal to 1.2. Mean and variance of the binomial distribution or the discrete distribution, that can be more than 1, but the probabilities of the binomial distribution or simple probability will never be more than 1. 1 represents 100% occurrence, whereas 0 represents impossibility. 0 represents impossibility of the occurrence. And if we talk about 0.5, that means there are the 50% chances, any chance may occur, anything may happen, that is regarding to the binomial distribution. If mean is there, mean will represent on average, whereas the variance, if the value of variance and the value of standard deviation will be least or minimum, that represents the more reliability, more dependence. While on the other side, if the value of variance, value of the standard deviation, that will be more than, that will be more than or greater value, that will represent the strong rather than strong, no strong, just the weak relationship or the weak variation. That means there is the more scatteredness, more variation in the data can't be reliable. Lesser standard deviation, lesser variation represent there is lesser scatteredness in the data, so we can rely more on the data, we can depend more on the data, and the value of variance is more and the standard deviation is more, that represents variation in data, scatteredness in data, that is more. So data wouldn't be reliable. To take the data on reliability basis, we have to keep in mind the value of the standard deviation and the variance. In nutshell, what we did today in today's lecture, we came across the concept of the probability, concept of the binomial distribution. Then we came to know under what conditions we have to apply the binomial distribution. Then we read about the properties of the binomial distribution, then the application of the binomial distribution, and we quoted the different examples regarding to the binomial distribution. That's all regarding to the binomial distribution. Inshallah, in the next lecture, we will proceed further regarding to the hypergeometric distribution and the Poisson distribution. In the next lecture, we will discuss upon hypergeometric distribution and the Poisson distribution. They are also the discrete distribution, but they are being used under different conditions. It is directed to the students. Please go through the lectures, come across the points, come across the values, then we will be in a position to make the right decision. So, all from my side for the today's lecture. In the next lecture, inshallah, we will proceed further regarding to the hypergeometric distribution as the and the Poisson distribution, which is being directed to the students. Kindly go through the notes, PPT slides, or any notes, any relevant material you can sort from the Google. You have to read that. Then we'll have a quiz in the next class on Thursday regarding to the probability distributions of binomial distribution, probability, and the hypergeometric distribution. Until then, take care. Allah Hafiz. God bless you. Stay at home. Stay safe. Take care.